Hello student, welcome to our lesson today where we are going to look at machines. We start with simple machines. First of all, we need to understand what is a machine, and this is a device that makes work easier. In a machine, a force that is applied at one point is used to generate a force at another point in order to overcome a load. So a load is now the force that is acting on the machine. And the effort is now the force that is being exerted by the machine. So we look at terms associated with machine. One, we have the effort. This is the force applied to the machine. The SI unit of effort is the Newton because it is a force. Then number two, we have the load. This is the force exerted by the machine. And the SI unit of load is again Newton. It is a force. Then from there, the third term, we have mechanical advantage. And we say that this is the ratio of load to the effort, which implies that for you to get mechanical advantage, you take the load, you divide by the effort. And because load has newtons as the SI unit and the effort has newtons, so the newton will cancel out, and therefore mechanical advantage has no units. So mechanical advantage is load over effort. So for most machines, the mechanical advantage is greater than 1, since the load is always greater than the effort. But in fewer machines, mechanical advantage is less than 1. For example, we have a bicycle. Effort is greater than load in a bicycle, and therefore mechanical advantage will be less than 1. Then we look at factors affecting the mechanical advantage of a machine. The first factor is the friction between the moving parts. So the greater the friction, the less the mechanical advantage. Then number two, we have the parts of the machine that have to be lifted. We have that the heavier the weight, the less the mechanical advantage. So these are the two parts or two factors that affect the mechanical advantage of the machine. That is the friction and the moving parts, or the parts of the machine that have to be lifted. So that is the weight of the moving parts of the machine. Then from there, we look at the fourth term, which is the velocity ratio. And now this one, we are going to consider the ratio of distance moved by the effort to the distance moved by the load in at the same time or at the same time. So velocity ratio is defined as the distance moved by the effort, dE, over the distance moved by the load, dL. So we can say that velocity ratio VR is equals to dE over dL. But if you have two machines, that is A and B, with velocity ratio of VRA and VRB respectively, when you combine, the resultant velocity ratio will be the product of two velocity ratios. So the velocity ratio of the combined machine will be VRA multiplied by VRB. From there, we move to efficiency. This one is the ratio of work output to the work input, and it must be expressed as a percentage. But what is work output? Now, this work output is the work done on the load. Therefore, work output will be load times distance moved by the load. And work input is the work done by the effort. Therefore, work input will be the effort multiplied by the distance moved by the effort. So from there, we can be able to get the relationship between mechanical advantage and velocity ratio and efficiency. We have defined efficiency as work done on the load divided by the work done by the effort. But we know that work is always given by the force times distance. So if we are talking of work done on the load, it will be the load times load distance. Work done by the effort, it will be effort times effort distance. But if you look at this part, load over effort is mechanical advantage. And dL over dE is 1 over velocity ratio, because velocity ratio is the distance moved by the effort divided by the distance moved by the load. So this is the reciprocal of our velocity ratio, which implies when you put the two together, Efficiency will be mechanical advantage multiplied by 1 over velocity ratio, and it must be expressed as a percentage. Therefore, our efficiency is mechanical advantage over velocity ratio times 100%. Efficiency of the machine depends on the friction between the moving parts and the weight of the parts that have to be lifted. And for these two reasons, the friction and the weight of the parts to be lifted makes the efficiency of the machine not to reach 100%. So we are saying for these reasons, or these reasons explains why the efficiency of a machine is always less than 100. We look at an example. A certain machine uses an effort of 400 newtons to raise a load of 600 newton. If the efficiency of the machine is 75%, determine its velocity ratio. We proceed as follows. Mechanical advantage is load over effort. We have the load, we have the effort. So we just divide, we get that mechanical advantage is 1.5. But we know that efficiency is mechanical advantage over velocity ratio. And we are given the efficiency as 75. Then we have calculated the mechanical advantage as 1.5. So we can be able to get the velocity ratio. So velocity ratio will be 1.5 divided by 75, and that must be multiplied by 100%. So when you multiply all these terms, you'll find that the velocity ratio is 2. From there, we can move to a second example. A crane lifts a load of 200 kg through a vertical distance of 3 meters in 6 seconds. Determine part A, work done, then part 2, power developed by the crane, and part 3, efficiency of the crane, given that it is operated by an electric motor rated 1.25 kilowatts. We proceed as follows. 1, we know that work done is equals to the potential energy. So work done will be the 200 times 10, that is the weight, then multiplied by the distance. So you get that it is 6,000 joules. Then part 2, you're supposed to get the power developed. Power is always given by work done over time taken. So you get your work done, which is 6,000 joules, divided by the time, which is given at 6 seconds. You get that power is 1,000 watts. Then finally, you have the efficiency. We know that from the definition, efficiency is power output divided by power input. So the power output is 1,000, this one. Then the power input will be this one, 1.25 kilojoules. So when you divide and then you multiply by 100%, you get that the efficiency of that machine is 80%. Then question number 3, a machine of velocity ratio of 4 needs 200 joules of energy to lift a load of 400 newton through a vertical distance of 2.5 meters. Calculate 1, the efficiency of the machine. Number 2, its mechanical advantage. We proceed as follows. Work input is this one, 2,000 joules. Then we have that the work output, it will be 400 times 2.5, you get 1,000 joules. Then the efficiency is always given by work output over work input. So it is 1,000 divided by 2,000 times 100. You get that it is 50%. So mechanical advantage is equals to efficiency times velocity ratio. So it is 50% times 4. You get that if you get 50 over 100 times 4, you get that the mechanical advantage is 2. Then from there we have the assignment. The assignment is just testing what we have just learned. So make sure that you attempt with confidence. So thank you, and let us meet in our next lesson.